So, in this video, I will teach you how to convert the octal to decimal and binary to decimal. We have here 777 in octal. So in binary it is 111111111. It is all 1. So to get the decimal using octal, this is the solution. You need to multiply it in the 8. Oh, 7 times 8 raised to 0. 7 times 8 raised to 1. 7 times 8 raised to 2. So 7 times 8. So 8 raised to 0 is equals to 1. So 7 times 1 is equals to 7. 8 raised to 1 is 8 times 7 is 56. And 8 raised to 2 is 64 times 7 is 448. And you will add all this and find the sum. So if you add this 8, 6, 7, 2, it is 1, 2, 1, 1, 5. It is 511. So this is 511. But if you will going to get the decimal using binary, here is the solution. 1, 1, 1, 1, 1, 1, 1, 1. You need to multiply it into 2. 1 times 2 raised to 0. 1 times 2 raised to 1. 1 times 2 raised to 2. 1 times 2 raised to 3. 1 times 2 raised to 4. 1 times 2 raised to 5. 1 times 2 raised to 6. 1 times 2 raised to 7. 1 times 2 raised to 8. So 2 raised to 0 is 1. So 1 times 1 equals 1. 2 raised to 1 is 2 times 1, 2. 2 raised to 2 is 4 times 1, 4. 2 raised to 3 is 8 times 1 equals 8. 2 raised to 4 is 16 times 1 is 16. 2 raised to 5 is 32. Raised to 1 is 32. I times 1 is 32. 2 raised to 6 is 64 times 1, 64. 2 raised to 7 is 128. Raised times 1 is 128. 2 raised to 8 is 256 times 1 is 256. So when you get the sum of it, it is 511. The same with the answer in using octal.
Right.
I'm Jasper Castillo. So today I'm gonna teach you how to convert decimal into binary and binary to octal. First, let's say for instance we have 130 in the decimal. So in able to get the binary, we need to divide it into 2. 130 divided by 2 is 65. 0. 65 divide into 2 is 32. So, when there is a 0.5 here, 65 divided by 2, 32.5, we need to put remainder 1 here. So, 32 divided by 2 is equal to 16. 0, 16 divided by 2, same process. 8, 0, same process. So, when we get this answer, we need to write it upward. So, we will start in 1. 1, 0, 0, 0, 0, 1, 0. So, to get the octal, we need this formula. 0 is equals to 0, 0, 0 because there is a 0, 0, 0. It is 1, 2, 4. So, it is 4. It is all 0 so that it is 0. So, when it is 0, 0, 1, it is 1, 2, 4. We count the 1. We only count the 1. So, 1 plus 0 equals to 1. So that it is 1. So, here, we need to cut it into 3 to get the octal. 0, 1, 0, it is 2. 2, 0, 0, 0, and it is 0. This one here is, it is not countable as 3. So, there is a imaginary 0 here. So, it is 1. So, the octal is 102. Cut. Now, I will teach you how to convert hexa into binary and octal and decimal. First, let's say for instance we have here an hexa A, B, C. In the formula of hexa, the A is equals to 10 and B is equals to 11 and C is equals to 12. It is 10 because 8, 4, 2, 1. 8 plus 2 equals 10. And this is 11. Same process. 8, 0, 1, 1. And 12, 1, 1, 0, 0. This is 11. This is 12. And this is now the binary. 1, 0, 1, 0. 1, 0, 1, 1. 1, 1, 0, 0. And to get that, we need to, and to get the octal, we need to cut the binary into 3. 1, 0, 1, 0, 1011 1100. Cut it into 3. So this is 1 2 4. So it is 4. And 1 2 4. 4 plus 2 plus 7. Plus 1 equals 7. And this is 1 2 4. This is 2. And this is 5. So our octal now is 5274. To get the decimal, we need to cut we need to multiply the octal into 8. So 5274 times 4 times 8, 0, 7 times 8, 1, 2 times 8, 2, 5 times 8, 3. So 8 raised to 0 is 1 times 4 equals 4. 7 times 8 raised to 1 equals 8 times 7 equals 56. 8 raised to 2 is 64 times 2 is 128. 128. And 8 raised to 3 is 512 times 5 is 2,560. 2,560. So 2,560 plus 128 plus 56 plus 4 equals 2,748. And this is our decimal. Okay, thank you guys. Okay guys, now I will teach you how to binary addition. So this is the formula for binary addition. 0 plus 0 equals 0, 0 plus 1 equals 1, 1 plus 0 equals 1, and 1 plus 1 equals 10, or 0 carry 1. Okay. So let's say for instance we have here 111 plus 0 1 0. So 1 plus 0 is 1, and 1 plus 1 is 0 carry 1. 1 plus 1 is 0 carry 1, and 0 plus 0 is 0 and bring down 1. So this is the now I will teach you the binary subtraction. So this is the formula for binary subtraction. 0 minus 0 equals 0. 1 minus 0 equals 1. 1 minus 1 equals 0. And 0 minus 1 equals 0. Borrow 1. So let's say for instance we have here 1101 and 111. 1 minus 1 equals 0. 0 minus 1, this is this is 0, borrow 1. So we have here 1 1. So it is 1. So it will be came 0 here. 0 minus 1, borrow 1 ulit. 1 1 tapos 1. So this is our answer for binary. Now, this is a 2's complement binary subtraction. So let's say for instance we have here 1 1 1 1 and 1 0 1 0. So we will copy this 1 1 1 1 and the first one in the denominator is 1 1 0. The first one is you need to copy 1 0 and the other is you need to convert or reverse. So this 0 will become 1 and this 1 will become 0. So you need to now you need to subtract it. 1 minus 0 equals 1. 1 minus 1 equals 0. 1 minus 1 equals 0 and 1 minus 0 is 1. And you need to bring down 1 here. So you need to add. So 1 plus 1 equals 0. Carry 1. 1 plus 0 equals 1. And you don't need to bring down the 0 because it is 2. Okay. So now this is binary multiplication. The formula for binary multiplication is 0 times 0 equals 0, 0 times 1 equals 0, 1 times 0 equals 0, and 1 times 1 equals 1. So let's say for instance, we have here 1, 1, 0, and 1, 0, 1. So 1 times 1 equals 1, 1 times 0, 0, 1 times 1, 1, and 1 times 1, 1. And this is all 0 because of the 0. 1 times 1, 1, 1 times 0, 0, 1 times 1, 1, 1 times 1, 1. And you need to apply the binary binary addition. So bring down 1, 0 plus 0, 0, 1 plus 0, 1, and 1 plus 1 equals 0, carry 1, 1 plus 1 equals 0, carry 1, so this is 0, 1 plus 0 equals 1 plus 1 equals 0, carry 1, 1 plus 1, carry 1 equals 0, and bring down the 1. So this is the answer for binary multiplication. I will going to teach you what is trace data structure. So trace data structure is the storage of data in algorithm. So this is the root the top nodes in the trees, and this is the child of the root. This is these two is siblings of the parent root. Since B and C have their own child, so we can call it parents. So what is subtree? Subtree is here. it has a parent, child, and siblings. So height, the height of the root is here 1, 2, and the depth is the lowest spot ay ano the shortest spot from the root. So since the height are both the same, so this is both height. When this is it has another node here. Let's say for instance S. So this is the height and this is the depth. Today I'm gonna teach you how to get the elements. So the elements is the variables inside the nodes. So we have here 1, 2, 5, 3, 4, and 6. And we go to the pre-order. So pre-order, the formula for this is the parent, left, right. So to get that, parent 1, left 2, left 3, and right. So since there's nothing any left there, so we go to the right, right and 6. So in order, left, parent, right. To get that, first the left 3, and then the parent 2, and then right 4. Then since we don't have any left, we get the parents 1 and parent of 6, 5, and 6. So in post order, left, right, parent. So left 3, right 4, parent 2, and then since we don't have any left there, so we begin in the right. So 6, 5, and then the parent or the root node 1. That's all.